All right, so why in the world do we want to factor or unmultiply? So let's see. If we want to factor or unmultiply, especially situations like this where we have a trinomial, we might be able to find some really interesting things. So let's graph the f of x on our calculator and fill this out. Fill out the table in number 2. And what I'll do is I'll do this and then I'll come back to the recording. Okay, so here's a graph from the calculator of x squared plus x minus 6 and the filled in table as well. So the next question asks us to solve x squared plus x minus 6 equals 0. So it's asking us, when is this f of x equal to 0? Well, let's see if we can find that in a couple of ways. One is f of x is the y value, right? So when is f of x equal to 0? And that's when it crosses the y-axis, the x-axis. So somewhere here and somewhere here, and it looks as though on the graph that would be at 2 and -3. If we were looking at the table, this is the value of f of x, 0 and 0. So that would happen at -3 and 2. So at x equals -3 and x equals 2. That's very interesting. So let's see if we could write x squared plus x minus 6 in unmultiplied or factored form. So let's say we have x squared plus x minus 6. So we have an x in here somewhere and minus 6. And the minus 6 would have to be a rectangle here. It could be like this. But that wouldn't leave us enough room for 0 pairs. We would need 3 negative rods and 1 positive rod. That doesn't quite make sense. But what if we drew this in the other orientation? And then we certainly would have 0 pairs to fill in our gap. So if we look at the factors, the vertical factor and the horizontal factor, and notice I shrunk the factor tracks, but the vertical, so f of x is going to be x plus 3 and x minus 2. Well, what does that tell us about the function? So we have now 4 ways that we've represented the function. We have the original equation that was given to us. We have a graph and a table. We know that, and we have this factored form. And we know that for all of these, the graph crosses the x-axis, or the function is equal to 0 at x equals -3 and x equals 2. So what do we know? And we identified those zeros for the graph and the table, but what do we know from this unmultiplied or factored form, which would help us identify -3 and 2? Well, notice we have these 2 numbers here. Now, what happens when x is -3? If x is -3, this term becomes 0. If you substitute in -3, this first term becomes 0. If x is 2, the x minus 2 becomes 0. So that's really interesting that in factored form, the x-intercepts, or where the value of the function is 0, happens when either one of these terms is 0. And that kind of makes sense, that if one of the terms being multiplied is 0, then 0 times anything is 0. Or something times 0 is 0 as well. So all it takes is for each one of these terms to be 0, and then we know that that's where the x-intercept is going to happen. Now, that's really helpful if you have the factored form. It's not so helpful if we're looking back at the original.